Hello friends, now we will see one problem for deflection calculation, and this is one university question for the year November 2014 for Annamalai University. It is a cantilever beam of span 2 meters. The cross section of the cantilever beam is 150 mm wide and 200 mm deep. It projects 2 meters out of your bar. That is, the cantilever span is 2 meters. Is carrying a point load of 40 kilonewton at the free end. Determine the slope and deflection at the free end. Take E is equal to 2.1 into 10 power 5 millinewton per meter square. Now, this is the cantilever beam. A is fixed end, B is the free end. Cantilever length is 2 meters. We have to get the moment of inertia of the member, that is BD cube by 12. This we are getting in millimeter per 4. The length is in meter. So we will convert this moment of inertia also in meter per 4 so that the units are inconsistent. So that the units will be consistent. Young's modulus is given as 2.1 into 10 power 5 millinewton per meter square. We will convert this into kilonewton per millimeter square. We will convert this Young's modulus into kilonewton per meter square because the loading is given in kilonewton and the span is given in meter. So we have to convert this into kilonewton per meter square so that the units are consistent. Now we have to calculate the slope and deflection at the free end. Now the slope at this point B is equal to theta B, and here this is theta B. This is a mistake. This is not theta A, this is theta B. Theta B is the slope at the free end. Fixed end, the slope is 0. At A, the slope is 0. At B, the slope is theta B. As per Morse theorem, theta B minus theta A is equal to area of the bending moment diagram between the points B and A into 1 by EI. Theta B minus theta A. Theta A is 0. So theta B minus theta A is equal to theta B itself. And that is equal to 1 by EI times into the bending moment diagram between the points B and A. Now, what is the bending moment diagram? Bending moment at any point X measured from point B is equal to 40 into X. This 40 is kilonewton is the load acting at free end. At any distance X, the bending moment is equal to 40 kilonewton into X. And we will consider an elementary strip of length width dx. So bending moment ordinate is 40 into x. Width of the elementary strip is dx. Area of the bending moment diagram is 40x into dx, and to be integrated between the limits b to a, that is 0 to 2. We are taking the section at a distance x from b. B is the origin. So the limits are ranging from 0 to 2. And that is what has been written here. This is theta B. This is theta B and not theta A. This is theta B is equal to 0 to 2. Area of the bending moment diagram. If bending moment ordinate is 40x, width of the strip dx. This is the area of the bending moment diagram. 1 by A times total bending moment diagram integrate between 0 to 2. So it is 40 by 2 into x square, 40 into x square by 2. So upper limit you substitute is 2 square by 2. Substitute the values of E and A. Then you will get 0.0038 radians. If you want to get the slope in degrees, multiply this by 180 and divide it by pi. This much into 180 divided by pi is equal to 0.69 degree. Now let us calculate the deflection at the free end, that is B. Suppose if you draw a tangent at A, the tangent will be horizontal because the slope at A is 0. A is fixed end. Fixed end means slope is 0. Theta A is equal to 0. At A, if you draw a tangent, it will be horizontal. And from B, you drop one vertical intercept. Then this intercept is called YB. This vertical intercept is equal to delta B, which is the deflection at the point B. Why? Because this is purely vertical intercept dropped from B to the tangent, which is drawn from the point A, which is perfectly horizontal. Therefore, this vertical intercept YB happens to be equal to delta B. And YB is the vertical intercept which can be obtained from Morse moment area theorem. Morse moment area theorem will give only the vertical intercept dropped on the tangent. Therefore, YB will be calculated by the Morse moment area theorem, and it is equal to delta B. And you are calculating the vertical intercept at B. That means the movement of the area of bending moment diagram should be taken with respect to point B. You have to consider the bending moment diagram between B to A, and this area of the bending moment diagram should be multiplied by the distance measured from the point B. And 1 by EI times moment of the bending moment diagram will give the value of YB, vertical intercept, and that is equal to delta B, the deflection. 1 by EI times. We have to consider the bending moment between B to A. Therefore, the integration 0 to 2. Bending moment coordinate 40 into X. 40 is the load at the free end. At any distance X, the bending moment is equal to 40 into X. Of the strip dx. Therefore, the area is 40x into dx. This is the area of the bending moment diagram. And you have to take moment about B, because we are getting the value of YB. We are getting the value of YB. Therefore, we have to take the moment of the bending moment diagram with respect to B. And this is at a distance of X from B. Therefore, into X, this is bending moment coordinate into dx, this is area into X, this is the bending moment of the bending moment diagram area. This is the moment of the area of the bending moment diagram. This is the area of the bending moment diagram, this is the distance. This much needs to be integrated between 0 to 2. So this 40 you can take it outside. This one will be the integral of x square, which is equal to s cubed by 3. Apply the upper limit 2, then it becomes 2 cubed by 3. EI is in the denominator. Now, after simplification, this becomes 0.005 meter. Multiply this by 1000, we will get the deflection in millimeter, that is 5 millimeter. Alternately, you can also use the formula theta B is equal to PL square by 2 EI. You can apply the formula delta B PL cubed by 3 EI. You can apply the formula. This is by using the formula. And I also request you to visit my website, https://rgnsite.wordpress.com. This contains nearly 500 university questions and answers, detailed questions and answers on various structural engineering subjects, RCC design, steel design, structural engineering for diploma examination, set of materials, structural analysis part 1, structural analysis part 2, moment distribution method, slope deflection method, influence line diagram, moving loads, arches, cables, and suspension bridge, matrix methods, force method, flexibility method, all these questions, steel design, RCC design, all these structural engineering subjects are covered by addressing nearly 500 university questions and answers, and the download is free. Download is free. Even in this, the question which we have seen just now, that is also available for free download in this blog address rgnsite.wordpress.com, https://rgnsite.wordpress.com. You can have free download of 500 university questions and answers, detailed questions, explanations, one word answers, questions, explanatory explanations. All the fundamental basic concepts are explained not only by means of explanations but also by addressing some of the important one word answers, one word question and answers. You can also visit my YouTube channel, that is RGM class. Thank you all.